Okay, hello everybody once again, whoever seen me yesterday, and so we meet again. Do you see my screen? In chat window, I would like to see the chat window. It's so unclear. Okay. Okay, so my name is Vadim, as you already heard it. And I'm gonna fix a mistake I made twice, actually. I tried to fit this talk into format of a lightning talk, and it never worked. So I would like to fix this mistake and tell you about TestAsync and why I think it should be interesting for you. Well, I have a habit of showing a lot of examples. And so if you want to follow my examples, you can clone the repository. And in the chat window, I have given the instructions how to clone and how to, which directory actually contains the examples I'm going to be using. So first of all, why TestAsync? A year and a half ago, I decided to make an experiment and create a windowed text mode framework. Like if anybody worked with Borland Pascal back in long years ago, maybe you remember TurboVision framework back then. There was a number of other frameworks of the kind. So I decided I wanted to have some kind of windowing system for Raku, and I decided to give it a try and implement. And I based the framework on event system, which in turn was heavily relying on threads. It used a lot of threads. And when it came to tests, I just realized that, well, using the core test module, it's using the Borland Pascal. Oh, sorry, it just on TRC, there is a notification that somebody noticed that I remember about Borland Pascal, so just a little bit of mess. So using the core test module causes me a lot of pain because it doesn't work with threading pretty well. So I decided to write my own test module, which would solve a lot of problems I was meeting. How? Well, the only answer to this question was I wanted my module to be a drop-in replacement for the core test. That was the only mandatory requirement aside of being threadable and concurrent and whatever else I wanted to see, but I want people to use my module too. And if they started using core test, I would like the switch to a new module to be as smooth as possible. So you can simply replace test with TestAsync and things are going to be broken. I promise you. Targets which I wanted to achieve apparently thread safe, as I said, primary. Another target was I wanted randomized testing. Randomized testing is something I picked up while working on FOSWiki project in Perl, and they use inconsistent order of test blocks. They use one testing system, but anyway, so they used inconsistent order to catch up possible errors where you forget something to clean up and it influences other code in an incorrect way and so on, so on. I'll get back to it a little bit later. And the thing I always like in any kind of software is simplicity of extending it. So I wanted the module to be extendable, easily extendable with third-party modules. So if you don't have enough in TestAsync, you can develop something you're missing it, and you can add it, and it has to be easy. Well, hopefully I made it easy. And yes, support for non-standard test environments, it also belongs here, because if you need something aside of tab output, standard test protocol, you just write an extension for TestAsync. Internally, I was targeting object-oriented architecture. That's something I always use. Even my small scripts I write for myself, they often based on classes, because simply when you get back to those scripts in years, it's much easier to remember what's been done and why it's been done this way or not other way. So event-driven as well. The idea of event-driven test module came to me from two sources. First, it was, of course, the framework I was developing back then, and also long time test2, I think, in Perl, also using the event-driven approach. So I picked up that idea. A little bit about terminology. I introduced my own terminology here because I found nothing appropriate, actually. I don't know why. So first of all, I use term test tool. Test tool is actually a subroutine which does the testing. In core test module, they are just called subroutines or functions or whatever. But I call them test tool. So if you use OK, if you use pass, plan, whatever, those are test tools. Test suite in this terminology has two meanings. It's a set, a code block, logically bound code block, which runs some number of tests by invoking test tools. And test suite is also the object which controls this code block. Test bundle is an extension. So basically, it's like a module, even though it's, well, actually it's a role, but again, I'll get back to it later. And I have a reporter. It's a test bundle which implements output functions, reporting functions. So whatever you get as an outcome from your testing, it gets there through the reporter. So how things are built internally? Since it's object-oriented approach, everything is built around one single class, TestAsync Hub. And they call it Hub because it's not the final class. It's a class which collects which, well, it's not, it not doesn't collect, but everything else binds to this class to form something final. By default and automatically, it pulls in aggregator role, which is responsible for event processing, and job manager role, which actually responsible for managing jobs. Job can be, it's a piece of code which does some kind of test, and job manager decides how this code should be run. And dynamically connected are test bundles and a reporter bundle. And eventually, out of all this, I produce test suite class. And this class is what I instantiate to get control objects for test suites. Here is a little bit about how it works eventually. So generally, we have a suite which runs a number of test tools. A bit earlier. Let's take one example. And actually, this is the test suite. And here we invoke a test tool. Don't mention it's just first example of several, and it's using core module test. I'll get to this. So test tool, say first one could be plan, second one could be is something, and last one could be is okay something or whatever, leaves okay. Each test tool eventually produces a sequence of events depending on what they are doing. One event is mandatory. It's an event which contains test results, apparently. Events are then fed to the aggregator role. Aggregator passes those events through a filter if one is installed by a test bundle. And filter can do anything. Filter can drop an event, it can inject another event or modify the event, whatever. So if you need to get into the chain and do something to the events, you normally would do it through a filter. Then events are streamlined in a single stream and sent down to reporter, which can report to user. Normally, this is TEP protocol, which we are all used to, but as well, it can write to a log. It's not implemented. It would require a separate reporter, or results of testing could be sent to a server. So I was keeping in mind that it's possible to create a test factory, for example, where you have a lot of testing machines around, and you can have one server which would collect test results, analyze them, report them, and so on. And with a specialized reporter, it is possible, and it's pretty much easy to implement, really. Okay, but this is basically a sequential, sequential scenario which we are all used to. And events here, they will be coming sequentially because test tools were called sequentially. But if you switch to a threaded model, if our suite contains threaded tests, which would emit events asynchronously and in parallel, whatever, well, nothing changes. TestAsync is written in a way that it doesn't care whether your test environment is synchronous and sequential, or is it asynchronous and threaded. It doesn't matter. Bundles. Here, just simple way of declaring bundles, but I really must apologize because talking about workflow, I wanted to show you some examples first, just to see things in action. So typically when we start with testing, say we have 3 tests run sequentially. And we all know this outcome of the core test tool. But what if we change this test a bit? What if we introduce threads? And we need to run each test in individual thread, whatever the reason for this. So throws like is invoked in a thread. What we get here? Uh-oh, look at the difference. Look here and look here. What a mess. And sometimes we even get failures because it's a mess. The core test is not designed for threading, and to make things working correctly, we need to take special measures, and we have to fight for correct test outcomes. But here is TestAsync, and we are back to normal. All I done, I replaced core test was replaced with TestAsync, and one mandatory change. I cannot. It's not possible to use the standard start routine, but a method of test suite object has to be used instead. But it's really minor change, absolutely minor, because otherwise, as you can see, things are basically the same. And another thing which actually is gone now, you see, just to prevent the suite to exit preliminary, because if I just start threads, they may not finish before the main code exits. So I have to record all the promises returned by the start, and I have to await for them. That's what I do with the core, but I don't need this with TestAsync. I just finish, and the rest is done for me automatically. TestAsync will wait until all those drops, those are the most simple kind of drop in TestAsync. So it will wait until all those drops are done. And as you can see also, this line, first line, it actually comes from here. So even though pass on the main, in the main script code was invoked last, but in the output it appears first, because for Raku it would take time to start a separate thread, and while it starts those threads, the main code could already be finishing its work. Okay. Sorry for repeating all this. And back to the bundles. So declaring a bundle is as simple as using a keyword bundle. That's all. Then when you need to create a new test tool, you just create a method and you apply test tool trait to it. And that's all you need. Nothing else. Here's an example implementation. Well, actually, to declare a test bundle, one would need a module from TestAsync, which would provide you with test bundle keyword and with the trait. But otherwise, this is a typical test tool. You declare it in a test bundle, then you use TestAsync, and then you just use your new test tool. And here we go. So first test tool passes because this is what it does. It checks if case insensitive comparison, well, actually lowercase comparison to full passes, and with bar, apparently it fails. Okay. And talking about the internal architecture, in the second example, I simply wanted to show you the inheritance tree of TestAsync. So if you look at it, you see that, as I told you, TestAsync Hub class consumes job manager and aggregator class. Then we have a reporter, tab reporter, which is included for us by default. And because test bundles are roles, I create classes which consumes those roles, and I build inheritance chain of those classes. So reporter is a child of TestAsync Hub here, reporter class. Base test bundle, this is the bundle itself here as a role. And this is the class created for it, and it inherits from the previous class. And here is my bundle. And eventually the custom created suite class inherits from all those bundles and eventually from Hub. So we have a chain of inheritance, which allows us to override other test tools or to override some internal methods of Async Hub. We can do a lot of things. Bundle is not only about creating own test tools, but it's about extending the module in many other ways. Another thing, what test tool trait does, it creates and exports a symbol for the method it is applied to. So we have method is full, and subroutine is full created for this method. It's a wrapper, which internally does some preparations, and eventually it calls the test tool method. And here is the demonstration of this, because I can use same test tool as a method on my test suite. This is important because when you create your own bundle, you can use other test tools from other bundles. You can use them as methods. And test reporter also, it's very easy. I wouldn't be showing you how to write a reporter. It's a matter for reading documentation. It's a little bit more complicated, but declaring it is also very simple, and it requires 3 methods to be implemented. And that's all. Okay, even though I already used examples quite extensively, but here comes the real examples session. Okay. First and foremost, of course, parallelization. In some cases, in some modules are supposed to work in threaded environments. And we need to make sure that the code we wrote is actually concurrent safe. The best way to do so is to start many threads and run some tests in those threads so that we make sure that they can cooperate nicely and safely play together. Here is how we do it. So let's start with sequential example, just to see once again. So this is normal sequential example. I use this node here to indicate what subtest code is currently ran. And I use it because when I use PES or when I use some other test tool, they all go through an event subsystem, and the output could happen not when you expect it to happen, because events are being processed asynchronously. So to have synchronous notification of when my subtest has been run, I use node. Usually we don't need it. It's only for the purpose of demonstration things. Okay, here we go. All I do, I supply plan test tool with the named parameter parallel. And that's all I need. From this moment on, by default, all subtests will be run in their own thread. So here, in this loop, I start 5 subtests, and each will be executed in its own thread as I promised you. And another thing I want to achieve here is to make this demonstration even more clear. I want those subtests code to be synchronized. I want all of them to fire simultaneously. And I actually succeed with it. And I have an approach which I would like to share with you. So normally, if you think about parallel processes, we can think about them as of runners on a stadium, where they have to start at the same moment of time. And to guarantee that they start at the same moment of time, they use a starting gun. So I have a starting gun in the form of a promise, and no subtest code will start until the starter promise will be kept. But that's not sufficient, because threads are starting asynchronously and they're starting pretty much unpredictably. And if I just keep this promise over here, it could happen so that some subtests already, some threads already started while others are still starting. So before keeping this promise, before firing the starting gun, I have to find out if everyone is ready. And here what I do. So I have top suit, and I have a number of subtests started. And top suit sits there in asking mode if everybody is ready already. And subtests are starting and signaling that they are ready, and they do so by keeping a dedicated promise here, which was generated for them outside of the thread in a loop. So I have an array of promises, and each promise is kept, and here the top suit is awaiting. Okay, since all threads are started and ready, we fire the starter, and subtests are started at the same moment. They resume basically at the same moment. So if I really need to test things in parallel, this is a good approach to synchronize and make sure that things are really being run simultaneously, more or less. well, as much as it can be guaranteed by the thread scheduler. Next feature, random testing. Using random testing is as simple as parallelized testing. All I need is just to supply random named parameter to plan, and all subtests will be created in a waiting mode. They will not start immediately. Instead, they will be put in a queue internally, and then the main code will proceed as usual. And then when we finish the suite, it starts processing this queue, and it randomizes the order of subtests and executes them eventually. So in this example, we can see it. Main works goes first, even though we don't use parallelization, you see. But this pass gets done first. And then I have all the subtests in random order. 0, 2, 3, 1. Okay, do it again. 3, 0, 1, 2. So whatever. Why random testing? With this example, I'm trying to show you just a mistake which could be done in your code. It's probably not realistic, but in some conditions, something like this could always happen. So in my class, I generate a unique sequential ID for each instance of the class and store it in attribute ID. And then I expect for some kind of number to come outside. And then this method reports the difference between ID and the number. And it actually expects that ID is always greater or equal to the number. So that's why we must always get an unsigned integer here. And if you do just normal sequential testing, I'm sorry, it's wrong example. Yeah, if you do just normal sequential testing, things just work. No problem here. Okay, so we switch to random. Oops. And without random testing, this kind of error would have slipped away. But when we have randomized testing, we have different situation here. The problem happens because when I start subtest and create an instance of the class in subtest, I supply it with test number, and because it's randomized, whereas ID will always be sequential, there are possible conditions where n will be greater than ID. This is always possible. And also, I would like to note that randomization and parallelization are not mutually exclusive. That's another situation which is very useful in some circumstances. As we all know, resources of our computers are limited, and if we run a lot of tests, a lot of subtests in a single suite, we might exhaust our CPU. To prevent this, TestAsync limits the number of simultaneously ran jobs. This number depends on the number of cores in your CPU. And if you have really many subtests and you want to run them in parallel, there would still be some amount of subtests waiting to be to be executed. So like you have 5 being run currently in their own threads and 10 more awaiting. And as soon as one of the executing subtests finishes, a new one is picked from the waiting queue and started. And without randomization, the queue is going to be also sequential. And with randomization, you randomize this queue so that, again, not only you run things in parallel, but the way subtests will combine with each other is also unpredictable. And it adds some amount of chaos to the testing, which allows to catch up with even more errors than before. So this is probably the most harsh testing conditions which could be created. And when? The other feature I missed a lot on many occasions. Somebody of you probably know about the module test when. By the way, how much time do I have left? Could you please tell me on the chat?
Yeah, you have to stop at 39 minutes.
Okay, so I'm over the time now. Okay, then basically I just was, it was enough to tell the main things I wanted to tell you. So just thank you everybody and hope you can find use for my module in your code. I think we have no time for questions left, as far as I understand.
We have 10 minutes more. Just
10 minutes more?
Yes. Yeah.
Okay. Then really I wanted to tell about when, because we all know different modes of testing: stress testing, network testing, whatever. And it's not always we want to run all the tests we have, and sometimes it's necessary to limit. So for this purpose, I created a standard bundle when, and what it does, it adds additional named parameter to the plan when, which limits the conditions under which our test should be run, like here. You see, it tells me the test is skipped because it expects concurrent testing. And concurrent testing here, it's not a variable in Raku, it's an environment variable. So if I do it like this, if I set an environment variable, it's oh, it's concurrent, so I do run. But the standard test when module was insufficient to me because I had pretty much complex condition ones where I needed something more complicated that it provides. So I decided to provide support for conditional, combinations of conditions. One of them is all. So all I do is I pass a pair to my when named parameter, and the pair has two conditions, concurrence and daemon. If I do it now, it tells me, okay, you're missing daemon testing. I need daemon testing or otherwise I won't be run. Oh, the conference demonstration. So this test to be executed needs both conference and demo testing variables. For simplicity, I don't request for underscore testing here. So it's added somewhere inside. Of course, some tests can be ran only if we have a specific module. And I don't have this module, so this is unconditionally skipped. But what if I want to run this test anyway? Okay, I can add force condition. And here we go. The test is run, but the second test fails because it tests for the presence of the module. And here I just use another kind of conditional, any. And well, that's basically it. And actually, nesting of those conditions is not limited. I can use all, or I can do all, and blah, 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 something else, some other condition goes here. I mean, it's not a problem at all. And every condition will be correctly reported to you. So when you read the error message, you will know for sure what exactly you are missing to run this test. Okay. Okay, really. Also, a feature which I was always missing from other test modules. This test tool, I call this kind of, this family of test tools, test testing. What it does, it inverts the outcomes of the following tests. So if the following test fails, it will mark it as passing. If it passes, it will mark it as failing. The reason, we create a new test tool and we want to know if it works correctly. So of course we tested for positive outcomes, and that's fine. But what if we know it's gonna fail and we need to test exactly the case when it fails? Like here, we know that is must fail when it got two different values here. Well, we cannot use to do because it's not to do. Because if is would ever pass this test, it's totally incorrect. So test flanks takes care of this situation. And here what we get. The test is okay. It failed because we expected it to fail. And the comment of this test is preserved. So we know exactly why it failed. And we know exactly that things are working as we expected them. Okay, so I think it's enough for today. Thank you, everybody. Thank you very much. And if there are any questions and time for them,